Hello, this is the media project for material science 321. Our topic is electronic configuration and the periodic table. My name is Yahya Al-Zahrani, and I will go over with the electronic configuration, and my friend Abdurrahman, he will spend the rest of this video talking about the periodic table. So we will talk about the electronics configuration. What is the definition of electronic configuration? Actually, electronic configuration for an atomic species, natural or ionic, allow us to understand the shape and the energy, of its electron. Moreover, the electron configuration is standard notation used to describe the electron structure of an atom. So under orbital approximation, we can say here, we let electron occupy an orbital, which can then solve by wave function, by singular wave function. Actually, the wave function is the solution for the Irvine-Schrödinger equation. By solving this equation, we end up with a three quantitative number. The first one is the principal quantitative number, and the second one, the angular momentum quantitative number, and the third one is magnetic quantitative number. Also, there is a fourth one, but it's not the solution from Irvine-Schrödinger equation. We call it the spin magnetic quantitative number, M sub S. So the principal quantum number actually indicates the shell or energy level which electron is found. The principal quantum number N can only be positive number, non-zero, and integral value like N equal to 1, 2, 3, 4, and etc. The angular momentum quantitative number it indicates the subshell of electron. We can also tell the shape of an atomic orbital with the orbital with this quantitative number. Like example, here we go like S. The angular momentum quantitative number for S is equal to 0, and for P subshell L equal to 1, and for D subshell L equal to 2, and for F subshell L equal to 3. And next slide I will go over and the angular momentum quantum number. The magnetic quantitative number, which we call M sub L. For example, if the angular momentum quantum number L equal to 1, then the magnetic quantitative number, it can go from positive L to negative L. For example, the P here, L equal to 1, the angular momentum equal to 1, then we go from negative L to positive L, minus 1, 0, and 1. The general rule of electron configuration, actually, there are set of general rules that are used to figure out the electron configuration for an atomic species. We have Aufbau principle, hand rule principle, and pull exclusion principle. Before continuing, it's important to understand that each orbital can be occupied by only 2 electrons of opposite spin. The following table will show the possible number of electrons can occupy each orbital in given subshell. For example, we know that there is like just only 2 electrons can occupy in one orbital, and we know that the S subshell only have 1 orbital, P subshell only have 3 orbitals, D subshell only have 5 orbital, and F subshell only have 7 orbital. If we multiply this number here by 2, because we know that there is only 2 electron can occupy in each orbital. If we multiply this number here by 2, we can find how many possible electron number can find in each orbital. For example, S subshell, it's occupied by 2 electron, and the last one, F subshell, can occupy by 14 electron. I found it easy to talk about the Aufbau principle, and I will go for it. Actually, the word Aufbau is German word. It's mean for building up, and we can call it building up principle. Uh, the left, actually the right side of this PowerPoint here, it's sorry, it's actually a chart describing the how we go from for the Aufbau principle from like increasing energy. So we know that one S2 actually is that it's less energy than 2S2. The order of occupation roughly represents the increasing energy as go from level to level, and the electron occupy the orbital such way that energy it should be kept as minimum. For example, we cannot fill S7 to 7F until that all orbital from 1s to 6p filled up already. And also this number here can tell us how many electron can found in this actually row. Like for 1s we know already 2. Yeah, I will go for this example here. We have carbon 6, and we have another example is calcium 20. So that there is like in carbon 6 electron, we can go to the electron configuration of carbon. So we know that we're going from the bottom, from the less energy to high energy. We can follow the row here. Is 1 is 2, which is have already 2 electron, and so 2 minus 4 6 is 4. So then we go for another row, which is mean 2 is 2, can occupied by 2 electron, and then we go, the number 3 is 2b6, but already we have, since we occupy 4 electron, we have only 2 electron left, 2p2. And another example, calcium, which have 20 electron number, almost the same. We can go from 1 is 2, 2 is 2, then 2p6, then 3 is 2. We already filled up with 12 electron, right? So 20 minus 12, that is 8. So we go 3 is 2, 3p6, and 4 is 2. So that means there is 8 electron here. 1 is 2, 2 is 2, 2p6, which is already 10 here, and then 3 is 2, 3p6 is 8, and 18, then 4 is 2 is 2 electron first. And I will let my friend Abdurrahman talk to the rest of the periodic tables.
So now let's talk about a periodic table. First of all, what is a periodic table? Periodic table is a table that shows the chemical elements and they are arranged in a very specific way. And I will talk that arrangement later. So first I'll talk about what each element has in the periodic table. And the top is the name of the element. And some periodic table that does not include the name and some does. And comes below the name is the number and it is called the atomic number. and it is represent the number of protons in the nucleus. And come below that is the name symbols. And sometimes is the first letter and sometimes is the first two letter. As you can see in the helium, the first two letter is H and E, and the symbol is He. And last is the molecular weight, and it is the ratio of the mass of one atom, and the unit of the molecular weight is gram per mole. And now I'll talk about the groups names, and now we'll talk about the most important groups in the periodic table. First, the alkyl metals, and they are located in group 1, and second is the alkaline, and they are in the second group, and third is the transition metals, and they are these elements that are colored in yellow, and halogens in the group number 7, and last is the noble gases, and they are in the last group. And these noble gases are the most stable element in the periodic table. Moving on, as I said, I will talk about the arrangement. So the first arrangement is the atomic number. The atomic number is increased from left to right and also increase from top to bottom. As you can see, hydrogen start with 1, and when we go to right, we go to helium, and they go increase and become 2, and increase from top to bottom. Hydrogen start 1, lithium 3, sodium 11, and moving on. Second, the valence electron. The valence electrons are electrons that located on the outer shell of the atom, and basically they are the electrons that can be easily removed from that atoms. And we can know the valence electron from the group number 1a, 2a, 3a, 4a, 5a, 6a, and 7a. So that group has one valence electron, and this group have two valence electron. That group has 3, and that group has 4. This group has 5, and this group has 6, and this group has 7. And for noble gas, there is no valence electron, and that's why I say they are the most stable element in the periodic table. Last thing is the electronegativity. Electronegativity is the tendency of the atom to attract an electron, and the electronegativity increase from left to right and from bottom to top. So the most electronegativity is the fluorine, and with 3.98, and the lowest electronegativity is with Fr, and it is with 0.7. That's the end of our video, and thank you so much for listening to our video.